All right, so we are taking notes in our factorization unit. So first thing we had was factor squares. Then we talked about prime factorization, and I'm going to go over a little bit with this just to talk about some misconceptions that I'm seeing. And then we have greatest common factor, which is listed here. So today, we're going to take this into polynomials. So up until today, we've been working with monomials. And today we are going to, we are going to factor a polynomial. So we are going to what's called factor out a GCF, which is really just undistributing. So all year we've been practicing with the distributive property, taking a value outside the parentheses and multiplying it into the parentheses. Today we're going to have that answer and we're going to undistribute. We're going to look to see what all of the terms have in common. So let's first swing by 95 really quickly just to talk about this prime factorization and some misconceptions that we're seeing in our work. So if I go to prime factorization, remember that when you factor, you're factoring and prime factorization, your answer should only include prime numbers. I'm having some students that are putting in 2, 2, 3, and 6. 6 does not get included in our final answer because 6 is not a prime number. It's a composite number. So my answer is 2, 2, and 3. 2, 2, 3. Because that 6 comes from 2 times 3. Right? So when we factor and we are doing a prime factorization, we only want prime numbers in our solution. Right? So again, look down here, this big number right here, my answers are only the prime values. I'm not including these composite values that I get each time I take out a prime value. I'm only writing down the prime values inside my answer. So let's go and take some notes. Oh, just kidding. Go back. We're going to have a practice page with this too. So we are going to factor on page 97, and then page 98 is going to be practice. And again, as we go through these notes, remember you can pause it at any time if you need to catch up or rewind if there's something that confused you. So we are going to factor out a GCF, which is undistribute. So we are going to be doing the inverse of what we've been working on basically all year long. Again, let's just remember that a GCF is the greatest common factor. Right? So it is what everything, all of the terms share this number. All of the terms can be divided by this value. And it's the largest number that they all have in common. Again, a great resource is going to be these factor squares right here to help us look and see what we are factoring out. So let's write down our directions first. Number 1, the polynomial. And here we're using the general term polynomial. It could be a binomial, it could be a trinomial, or it could be a 10-term polynomial, right? The polynomial must be written in standard form. So I want to make sure that it's written largest exponent to smallest exponent. So our exponents need to be in order from least to greatest. Then, after we make sure that it's written in standard form, we are going to find the GCF of all the terms. All right, so I'm going to be using my factor squares, and I am going to be looking to see what do all of these terms have in common? What can they all be divided by? Don't forget that you're looking at the coefficients and the variables. They may only have a variable in common. They may all share an x. They may have no coefficient, but a variable. They could have just a coefficient and no variables in common, or they could have both. So then after that, we are going to divide each term by the GCF. And this is where our division skills, our division knowledge of exponents comes in handy. And this division part is the undistributing. Because when we distribute, we multiply each term by that value. Well, we're going to undistribute, so we're going to divide each term by that value. And then our last step, let me grab this, will be to write the solution. And the solution here is really the original problem. What we usually look at as the problem that we see, oh, look, there's a problem with parentheses. We have to get rid of those. We're actually creating this original problem. Meaning the GCF goes outside the parentheses. The GCF is going to go outside the parentheses, and the quotient, the answer to the division problem, goes inside the parentheses. And I'm going to walk you through this. Excuse me. Got something stuck in my throat. So here we go, example. Start out pretty small numbers, right? Pretty basic. 3x squared plus, no, that's to the third. 3x to the third plus 12x squared plus 9x. So use your factor squares. Use your factor squares, use your factor squares. If you don't use your factor squares, we can use some prime factorization rules. 3 is prime, so that's just 3x, x, x. 12 is 2 and 6, and 2 and 3. So 2 times 2 times 3 times x times x. And 9x is 3 times 3. So 3 times 3 times x. Right, so I factored each term. And I'm looking to see what do they all have in common, right? So they all share a 3. And they all share an x. So the GCF is 3x. That's my GCF, my greatest common factor. And if you are using your factor squares, you would look at 3, you would look at 9, and you would look at 12 and see what is the largest number that they all share. Well, they all share a 3. It's the greatest number. And if I look, I have 3 x's here, I have 2 x's here, and I have 1 x here, so they all share a 3 and 1 x. So now I'm going to take my problem, 3x to the third plus 12x squared plus 9x, and I'm going to divide it by 3x. And you will get to the point where you start doing this mentally. You don't have to write all of this out, right? You're going to be able to go through and see what's missing and what's going on. But 3x to the third divided by 3x. 3 divided by 3 is 1. X to the third divided by x leaves behind x squared. 12x squared divided by 3x. 12 divided by 3 is positive 4. X squared divided by x is x, because 2 minus 1 is 1. And then 9x divided by 3x. 9 divided by 3 is positive 3. And x divided by x cancels out, so I'm left with this. So this is my quotient, right? My solution, remember up here, right? Step 1, written in standard form it was. Step 2, find the GCF for all of them. Step 3 is divide. And step 4 is my solution. My solution is going to be the problem. So the GCF goes outside the parentheses. My GCF was 3x. And the quotient, the answer, goes inside the parentheses. So x squared, I can drop that 1 coefficient, plus 4x plus 3. And I just have factored out the greatest common factor. This is my solution. I've factored the polynomial. All right, we're going to do some more practice on the next page. So here we go, practice. And if you want to, you can pause in between problems and we will keep working through them. Question 1 is going to be 36f plus 18f squared minus 3. Question 2, negative 42x to the 5th minus 96x to the 4th minus 22x. Question 3, negative 230x to the 4th y to the 5th plus 136x to the 3rd y squared. And 4, nope, there is no 4, just 3 problems. Okay, so let's talk through our steps again. Step 1, which you can find over here, the polynomial must be written in standard form. This problem, not written in standard form. So the first thing we need to do is fix that. So I'm going to rewrite that as positive 18f squared plus 36f minus 3. Now it's written in standard form so I can continue. I'm going to look for the greatest common factor of 18, 36, and negative 3. I'm not including the f's in this because my last term does not have a variable. So they do not share a variable because one of my terms is a constant. So I'm going to go to my factor squares, 18, 36, and 3. Well, 3 is prime, so they need to have 3 in common because the biggest number 3 can be divided by is 3. So can 18 be divided by 3? Yes. And can 36 be divided by 3? Yes. So the greatest common factor, the GCF, is 3. Using this color. So my GCF is 3. So my solution is going to be 3 is on the outside of the parentheses, and I'm going to divide each term by the greatest common factor. 18f squared divided by 3, right? And again, something that you can look at, 18 divided by 3, well, it's paired up with 6, so that's my answer. 6f squared. 36f divided by 3. If you don't have a calculator handy, 36 divided by 3, it's paired up with 12. So plus 12f that. And negative 3 divided by 3 is negative 1. And there is my answer. I just factored it. Let's try the next one. Is this written in standard form? 5, 4, and 1. Yes, this is written in standard form. However, it has a leading negative, right? If that leading negative, right, if that coefficient, if it starts with a negative, I need to take that negative 1 out. Right, I have to factor out that negative 1. So that leaves behind 42x to the 5th. That changes to plus 96x to the 4th. And that changes to plus 22x. I'm going to look and I'm going to see the GCF. What do 42, 96, and 22 have in common? Do they share a variable? They actually do share 1x, right? So I know that's part of my GCF. And now I'm going to go and I'm going to look. I'm going to start with the smallest value. And I'm going to look. What does 22, what can 22 be divided by? Well, the biggest number it can be divided by is 11. So 22, then let's go to 42. Can 42 be divided by 11? No, it can't. So go back to 22. Oh, 22 can be divided by 2. Can 42 be divided by 2? Yes. And 96, can 96 be divided by 2? Yes. So the GCF, the greatest common factor for the coefficient is 2, and they all share at least 1x. Remember, I took out this negative 1, so I'm going to put that in here eventually, right? So my greatest common factor, right, is going to be negative 2x. I'm going to divide by 2x right now, but remember that negative has to go with it. So here we go. 42x to the 5th divided by 2x is 21x to the 4th. 96x to the 4th divided by 2x is 48x to the 3rd. 22x divided by 2x is positive 11. My GCF goes in front, but remember I took out a negative 1 at the beginning, so it's not just 2x, it's negative 2x. All right, let's do one more. All right, so again, down here, let's see, is it in standard form? First question. 4 plus 5 is 9. 3 plus 2 is 5. Yes, this is the greater, so it's going to stay here. If you notice again, I have a leading negative coefficient, so I'm going to take that 1 out, negative 1, and leave behind 230x to the 4th, y to the 5th, minus 136x to the 3rd, y squared. All right, now some of you may be saying, this is long. I have no idea what the factors of these numbers are. You're right, I don't either. So when we have values that aren't on our factor squares, unfortunately, you're going to have to factor them. So 23 and 10. 23 is prime. Don't believe me? Go look. And 10 is 2 and 5. I don't need to worry about my negative right here. I mean, I can take out negative 1 and 136. It's not going to affect my GCF because this one was positive. But 136, well, I don't know those off the top of my head. It's not an easy one, so let's just go with 2. 136 divided by 2 is 68. 68, let's go 2 again. Divided by 2 is 34. Let's go 2 again because it's even. 2 and 17 prime. So then I ask myself, what do they share? Well, I have 2 times 5 times 23 times 1, 2, 3, 4. 1, 2, 3, 4, 5. And then this is -1 times 2 times 2 times 2 times 17. X, 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 Y, Y. And they share a 2, an X, an X, an X, a Y, and a Y. So the GCF, believe it or not, is 2, 1, 2, 3, X to the third, Y squared. Okay, let's factor out our answer. 230 divided by 2. 230 divided by 2. I'll rewrite it down here so you can see it. 230 x to the 4th, y to the 5th, minus 136 x to the 3rd, y squared. I'm dividing that by 2x to the 3rd, y squared. 230 divided by 2 is 115. 230 divided by 2 is 115. X to the 4th divided by x to the 3rd, x to the 1st. 4 minus 3 is 1. I don't need to write the 1. Y to the 5th divided by y squared is y to the 3rd. -136 divided by 2 is -68. X to the 3rd divided by x to the 3rd cancels. Y to the 2nd divided by y to the 2nd cancels. So my answer, 115 is my quotient. It goes inside the parentheses. And my greatest common factor goes outside. However, remember, I had a -1. So it's not 2x to the 3rd y squared. It's -2x to the 3rd y squared. All right, factoring. Factoring out a GCF from a polynomial. Follow these steps, right? These are your steps that you're going to follow. These are the things that you want to look at. Use your factor squares, and good luck. I am here if you have questions.